For example 2, given the graph of the function f of x, we're going to find the following limits if they exist. For the notation, the limit x approaches negative 3 from the left of the function f of x as part A. We target the value negative 3. The negative 3 on the graph would be at that position. And then we look for the direction of the function as x approaches negative 3 from the left. The function value approaches to the value 5. So for part A, the answer is 5. Part B, limit of the function as x approaches negative 3 from the right. This time we're going to look at the graph as graph coming to the value from the right side. So the value of the function approaches to the value 6. The answer for part B is 6. Part C, the limit of the function f of x as x approaches negative 3, no superscript, either negative sign or positive sign. So that means we are looking for the two-sided limit. If the two-sided limits from the left and from the right, as part A and part B, they are not the same. If they are not the same, we can say that the two-sided limit does not exist. Part D, we're going to find the limit of the function as x approaches 1 from the left. Now we're going to target the point 1. As x equals 1, from the left side as a superscript negative sign here, we look at the graph for the graph of the function. As the function approaching 1 from the left, the function value approaches the value 2. So that number. For part E, limit of the function f of x as x approaches 1 from the right. This time we're going to look at the graph as coming toward to the value 1 from the right side. The function also approaching to the value 2. So in part F is a conclusion for the two-sided limit. As x approaches to the value 1 from both left and right side. For part D and E, they both are coming toward to the same number, which is the number 2. So we can say that the two-sided limit of the function f of x as x approaches 1 is 2. For number 3, given the graph of the function gx, find the following if they exist. Part A is the function value, the g at 2. If g at 2, that means we just look at the point x equals 2, and then the function is given the value as the value negative 1. So part A, the answer is negative 1. Part B, limit of the gx as x approaches to negative or 2 from the left. Target the value 2 again, but we are going to look at the function as x approaches 2 from the left side, the graph approaching to the function of the value of the function approaching to the value negative 1. For part C, limit of the function g as x approaches 2 from the right, that means we look at the right side of the curve as x approaches 2 from the right. You can see that the function graph approaching to the value 5 for part C. In part D is the conclusion of B and C because we are looking for the two-sided limit of the function g as x approaches to B and C don't give the same value of the limit. Since the left-hand side limit is negative 1, the right-hand side limit is 5. So we can say the limit of the g as x approaches 2, or the two-sided limit of the g as x approaches 2 is, we can say does not exist. Because the left-hand side and the right-hand side limit are not the same. For part E, g at 4, that means we are looking for the function value similar to part A. In this case, again, we look at the point 4 and the function value based on the graph, there is a hole. So that means the function is not defined. Part F, we're going to look at the limit of the g as x approaches 4. No superscript, that means we look at the two sides of the graph or two-sided limit. For number 4, as the function coming from the left side of the number 4, the function value approaches to the value 2. So this one, we can say the limit of the gx as x approaches 4 from the left is 2. And also look at the limit of the function g as x approaches 4 from the right. For this graph is also 2. So therefore, the left and the right-sided limit are the same. We can say the limit of the function g as x approaches 4 or the two-sided limit equals 2. Next one, part G, the limit of the gx as x approaches -4. Look at the point -4. No superscript, that means we look at the left side coming to the value 3, the right side coming to the value -2. The two-sided limit of the function g as x approaches -4 does not exist, because the left-sided and the right-sided limit are not the same. One side approaching 3, the other side approaching -2. The last one, the limit of the function g as x approaches -1. For the point -1, the left-hand side approaching to the value 4, the right-hand side approaching the value 4 as well. So this case, the two-sided limit of the g as x approaches -1 equals 4. Another example, given the function hx as a piecewise defined function is defined to be 0 for x less than 0, defined to be 1 as x greater than or equal to 0. Estimate the value of the following. For part A, we find the limit of the function h of x as x approaches 0 from the left side because the superscript is negative sign. The left side means x is slightly less than 0. From the piecewise defined function, x less than 0. So as x approaches 0 from the left, we're going to take this defined function as h of x equals 0. So then the limit is 0 for part A. For part B, limit of the function h of x as x approaches 0 positive. 0 positive, that means x is slightly greater than 0 or the x coming to the 0 from the right-hand side. If you draw the real number line from the right-hand side, that means the value is a little bit greater than 0, which is different than part A, which coming from the left where the x is less than 0 for that case. As the function h of x defined to be 1 for x greater than or equal to 0, so then the limit equals 1. At C, no superscript either plus or minus sign. This case we look for the two-sided limit. The limit h of x as x equals 0 from both sides. From A and B, the value of the limit are not the same. Therefore, the limit h of x as x equals 0, the two-sided limit does not exist. The last one, the function h as 0, this one doesn't ask for the limit value, but asks for the function value. The function value of the h as 0, for x equals 0, we're going to take the second piece of the defined function because x equals 0 is included for that option. Therefore, the h as 0 going to be 1.